We're always talking about teaching computers to think. I don't mean just crunching numbers. I mean really learn. It sounds like something out of a movie, right? But it's not. It's happening as we speak. And a huge piece of that puzzle, one of the key ingredients, is this amazing tool called Pytorch. So today, we're going to pull back the curtain and demystify it.
Okay, but before we get into the heavy stuff, let's start with a fun little challenge. Imagine I gave you a computer and said, your job is to teach this thing to tell the difference between pizza, steak, and sushi. How would you even start? Seriously, think about it. You can't just program a rule like pizza is round and has cheese. What about Sicilian pizza? That's square. What about a white pizza with no tomato sauce? You see, it gets really tricky really fast.
And that right there, that simple little food problem, it actually points to one of the biggest challenges in all of computer science. When the rules are fuzzy, or when there are just a million different possibilities, how on earth do you write code for that? How do you program for a world that's messy and unpredictable? So, let's think about this with an analogy. A recipe. Traditional programming, that's like a super strict recipe. Step 1, cut exactly 3 carrots. Step 2, preheat the oven to exactly 400 degrees. Step 3, cook for 30 minutes, not a second more. It works perfectly for things where the rules are clear and never change. But trying to write a recipe to identify a pizza, oh man, your recipe would be a million pages long with all these if this then that rules. It's just not practical. Now, let's take it up a notch. Forget pizza, what about driving a car? Can you imagine trying to write down every single rule for every possible thing that could happen on the road? A kid chasing a ball, a sudden rainstorm, a weird detour? There's no way. It's impossible. The real world is just too chaotic. Clearly, we need a totally different way of thinking about this, a completely new kind of recipe. And that new approach? Well, that's where machine learning comes in. And that's exactly what tools like Pytorch are built for. The whole idea is to flip the script. Instead of giving the computer that super strict recipe, we just give it a ton of ingredients, which is our data, and we let it figure out the recipe. It learns by, tasting and adjusting over and over again. So what exactly is Pytorch then? The simplest way to think about it is like a toolbox, a really powerful one for building and training AI. More specifically, it helps us create something called neural networks. And these are pretty cool. They're basically computer systems that are loosely inspired by how our own brains work, with all their connections. Their whole job is to find patterns in data that we might never see ourselves. And look, this is not some obscure tool just for researchers in a lab. We're talking about the engine behind tech you probably use every single day. The AI that powers Meta's stuff? Yep. The magic behind a Tesla's self-driving features? You got it. Pytorch is the absolute foundation that giants like OpenAI and Microsoft are using to build what's next. It's a huge deal. Okay, so a computer can learn from ingredients, from data. But before it can learn from a picture of a pizza, or literally anything else, we have a problem. We have to translate it into a language the computer actually speaks. And what language is that? It's the language of numbers. This right here is probably the most important rule in all of AI. Rule number 1, everything has to become numbers. It doesn't matter if it's a picture, a song, or a sentence from a book. Before an AI can touch it, it has to be turned into numbers, no exceptions. So let's bring you back to our pizza example. A digital photo isn't really a photo to a computer, right? It's just a giant grid of tiny dots, or pixels. And every single one of those pixels has a color, and that color can be described with numbers, like how much red is in it, how much green, how much blue. So suddenly, that beautiful, cheesy slice of pizza, well, to the computer, it's just a huge spreadsheet of numbers. That's all it sees. All right, so we've got all these numbers. Where do we put them? This is where a super important idea called a tensor comes into play. A tensor is just the special container that Pytorch uses to organize all of this numerical data. Seriously, that's it. Think of it as the universal mixing bowl for our AI recipe. Doesn't matter if it's one number, a whole list of numbers, or that giant grid from our pizza picture, it all gets dumped into a tensor. Okay, cool. So we've got our ingredients, right? All our data is chopped up into numbers and sitting neatly in these tensors. Now, it's time to actually start cooking. Let's walk through the step-by-step recipe for how a model in Pytorch actually learns. And you know what? The overall process is actually pretty straightforward when you break it down. There are really 4 main steps. Step 1, you got to prepare your ingredients, your data. This means getting tons of pictures and carefully labeling them. This is pizza, this is steak, this is sushi. Step 2, you build your model. This is like designing the chef's brain, the neural network. Step 3 is the big one, training. This is the actual cooking, where all the learning happens. And finally, step 4, you make a prediction. You test your chef on a new dish it's never seen before and see how it does. But let's pause on that third step for a second. Training. That's where all the magic is. But how does a chunk of code and numbers, learn? What does that even mean? Well, it really boils down to a super simple but powerful cycle. It's all about guessing and then correcting your mistakes. So, here's how it works. First, the model makes a guess. It looks at a photo of a pizza and says, I'm pretty sure that's steak. Then, something called a loss function comes in. The best way to think of this is like the official taste test. It takes the model's guess, steak, and compares it to the right answer, pizza, and then it calculates a score of just how wrong that guess was. A really high score means, wow, that was a terrible guess. The dish tastes awful. Okay, so what do you do with that bad score? This is where the optimizer steps in. The optimizer is our master chef. It sees that terrible score from the taste test and goes, whoa, okay, that was not right at all. And then it does something brilliant. It goes back and smartly adjusts all the thousands of little internal knobs and dials inside the model to try and make the next guess just a little bit better, a little less wrong. And that's it. That's the secret sauce. This whole cycle of predict, measure the wrongness with the loss function, and then adjust with the optimizer, it just happens again and again and again. We're talking thousands, sometimes millions of times. And with every single loop, the model gets just a tiny bit less wrong. That process, that constant tiny improvement, that is what we call learning. So let's zoom back out for a second. This whole process we just talked about, turning things into numbers and then learning through endless trial and error, this isn't just a neat trick for identifying food. This is the fundamental engine that's powering almost all of modern AI. It's the technology that's quietly working behind the scenes in so much of the stuff we use every day. And this whole deep learning thing, it's especially good at a few types of problems. First, anything with a crazy long list of rules, like trying to spot credit card fraud. It's also perfect for situations that are always changing, like a self-driving car trying to navigate a busy city street. And maybe most importantly, it's amazing at finding tiny, hidden patterns in huge amounts of data, like helping doctors spot diseases in medical images way earlier than a human ever could. And here's the part that just blows my mind every time. The core recipe, the fundamental idea we just walked through, it's the exact same one used for something simple, like telling pizza from sushi, as it is for something mind-bogglingly complex, like powering Tesla's autopilot. I mean, the scale is massively different, sure, but the basic idea, it's identical. So yeah, we started this whole journey with a pretty simple question about food, but it leads us to a much, much bigger one, doesn't it? If we can teach machines to see a pizza using this incredible recipe for learning, what will they learn to see next? The possibilities are just staggering. What we've unpacked today isn't just about code or a tool called Pytorch, it's about a brand new way of solving problems that, not too long ago, we thought were completely impossible.